Ah, for the project group, so you have to go to e-learning and just set your group or project. Oh, you already done that. Thank you. Even I didn't tell you. Thank you. That's it. And you submit the file here. Okay, go to lesson number 9, download file. That is the conveyor frame. And in this lesson, we will do the beam elements. And as we know from the previous problem, that we have shell elements and solid elements together, we have to create a connections. And on this one, we will have a joint to connect between beam. And also we have to bond, so to make sure it's connected, so bonding the beam together and just do the analysis and show you the result that what we have on beam elements. Okay, open the file. Okay, got it? Start. Okay, on the conveyor frame, so we have beams connect and just construct as a frames to get some support, some load. The load we apply on two beam here. Okay, and that means all of the distributed load will go on that beam, and that makes all the constructions have stress. Okay, the beam, as you can see, is have connections, and this is connection. So when you do some analysis, so actually the solid element can be used, but that will create a mesh for overall of the thickness of the beam. And that's make you remember at least you need 2 layers of solid elements on the thickness. So that will lead you to the plenty of number of mesh, and that will get you to consume you a lot of computational cost on your computer. So for beam elements, the properties we have, the cross-section area of the beam is constant. And all of the constant cross-section area will get like the same stress at that section. So that means we don't need to use solid elements to consume lots of computer cost, but we can use just beam elements. Okay. Okay, to create the study on the beam element, so we go to, we already have 5, so let's go for simulation options again to check every step that we have in the place. I will use the units of SI unit the same. For the stress or pressure, just change to megapascal. Okay, the mesh is high quality. This is show the result of floating number with 3 decimal. That's what I want. That's it. Okay. And then create a study. New study. The name is up to you. And then okay. got the same thing as me? Okay. The color pink and the yellow color that show you the joint. So if it's in pink, so that means they have a connections from all the beams. And if it's yellow, it has no connections with all that. That just a to classify the joint. That says the connection. Okay. And then if we go to the parts of conveyor, okay, you will see all the beam here. If you click, it will show you on the features of your selected, like that. And in the folders of cut list, it also have the beam. So to put the analyze together for all of the beam, so we will delete the folder. So we go to cut list and then click delete. Yes. And that will make all the beam came out of the folder and put it in the module tree for all the. That's it. Okay, just delete the cut list. Okay, and then in your model 3, you will see something different that we haven't seen it before, is the joint group in beam analysis. Okay, so when we do the solid analysis, a solid element, shell element, it doesn't come with that joint group, just for beam elements. Okay, we don't do anything on that yet. Then, before we go to the joint group, so let's set the material. So for the material, we use plain carbon steel for all. Apply, close. Let's check on your module 3 that have plain carbon steel in the blanket for all of the beams. Okay. And then now we go down. For the joint group, if we choose edit, joint group and edit. So it will show you all of the joints that you have in your structure. The list here is have a lot. Okay, on this one, okay, let's say they already calculate if they don't show the result of joints, so you can just click calculate that, they will show you this joint. And if you click on the joints, that will just pop up the color of selection star that tell you where is that joint. So we just review. So all the instructions, all the construct is already completed, so we don't change anything, just check that they have joint. That's for example, on this one. That will mean the connections between this one and the other one here for the structure. That's all the joint. It means the pink one is mean the beam have a connect to all the beam. That's it. Okay, just check. And if some of you have didn't show, maybe you just click display shear center. Just edit joint again. Click on display shear center. Okay. That would be the line of shear center of your beam. Okay, and then we're going to create a restraint, the conditions. Go to the feature, fixed geometry. And on this time, we will use the standards of fixed geometry that we will say is immovable. So it's different from the fixed geometry because fixed geometry is not allowed to move linearly and it's not allowed to move rotationally. For immovable, it just only fixed on the translational direction solid. That means no move linearly. Okay, and then we just select that joint, 4 joints for 4 legs. Select joint. Because now your structures, the program you see just only a beam, just a single line on each beam, not all of the profile. So you can select by the joint. Okay, the fixed geometry standards used as a immovable, just no translation. Okay, and that's it. And create the figure again, fixed geometry. And on this time, we use the normal fixed geometry, which is no translational and no rotational on this and this. So I selected, yeah, correct one. 2 legs in front and inclined blade. That's it. Okay, and then we apply some load. Go to the external load and let's say force. So on the selections, they have shown you this, which is mean point, and the other, which is mean joint, and the list that will be beam. So just choose the one that you want on apply load. So for me, in this case, I will apply for all along of the beam length. So just choose the type of selections to be beams and select 2 beams here. We will apply load on that beams. And then for the pink area here, so we need a reference plane to tell the directions of the force. So we can just take maybe top plane. You see the top plane here? This one. And I will just say the force is normal to that top plane. And that tells the force, the load at 67,000 Newton. And you see the arrow on the preview? I don't need that up. I need it to reverse down on these directions. Okay, reverse direction too. Apply force, compress the beam down. Okay. Click OK. And then you apply all the loads, which is different type. Say, go to external force again. External force again. And then this time, the selection type, we choose a joint. The joint. So I would like to apply the load on this joint here. And then go to the pink area, select the reference surface, reference plane. So I will try to create rotational on that joint. So I will take the front plane to be reference. Okay, and let's say force and also moment. For force is 45,000. For moment, 2,260 Newton meter. That means torque or moment that we create on that joint. So you may not see the symbol clearly because it's too small. So you can change the color here and maybe change the scale, maybe like a 2000s. Let's see that obviously. The load applied on that joint in the axial directions and also the torque or the moment on that joint. You can use right hand side on that symbol to see the directions of torque. Okay, and then create image. That's what you have. This is we use just default. It didn't change anything. That create image. Okay, and as you can see, your image or the elements will be just how can I say it, like a cylinder, a small cylinder, chop it in a small pieces. Okay, and that be like a node of your element. Okay, and if you would like to show the feature of your model, so we go to the simulations option again and go to the default options tab. And then the mesh. If you say it's render beam profile, okay, simulation options, default options, mesh. That is a high quality mesh. So we go down to see the render beam profile. So that will try to show you close to the actual of the cross-section area. Let's try to mesh again. That will change to the profile that you have. But the mesh that taking into the calculations will be like that. But this one is just rendered to just for user to see the profile of the beam clearly that have a different profile. Here it's just rendered for graphics. Okay, that's it. And then we go to run. Okay, got the result. So the results, the first one show you prototype is the stress. Is the stress just for the axial and bending only because it's beam element. And another result show you the displacement like this. So the scale is quite big, 42 scale deformations, deform shape. That's quite big scale. That's why the structure show you like a strange shape. You can just let them show another plot, like a stress plot, and you can choose the order. And you can just take the render out if you don't want. If you want, just have it on. And you can take for all the order stress, like a shear in direction 1, take it to scale. Yeah, that's it. It should be like this if it's true scale. And this is shear in direction 1. Okay, and they have quite a lot of result that you can just beam diagram. Yeah, you can just choose the moment of just only this. Yeah, or this two beams that you select to show the moment. That's it. It show you that is moment. Two beams are loop strengths, so just delete one. This is the moment in the beam. Okay, to the result that you can select it. List beam force. List beam force. Force or stress. Yeah, that will show you the stress on the beam list. And also we have probe to measure for example, we see that structure and click on update, and that will show the value of bending. Yeah, that's two main results showing you on that. Okay, you can just play it yourself.